Hi everyone, good evening. Thank you for making the time to come to our offices today. Um, from our perspective, it's wonderful to have all of you here with us. Um, when Things Network approached us and Anup spoke to me, I said, why not? Because it's good to get these kind of events organized, which advances the use of technology for the benefit of everyone. So, from my perspective, a little bit about who we are. We are relatively new in town, in Adelaide. Enzen, as an organization, was formed in 2006, 12 years now. We focus exclusively in the energy and water markets and their application across different industries. So, we started in UK and in Bangalore and India. We were 5 employees when we started, and with a vision to make a difference in the energy and water sectors globally. And over that last 12 years, we have now grown to a team of 3,500 people around the world. I was one of those five when we started back in 2006. And today we operate in 14 countries. And through our invested companies, today we have a presence in over 40 countries around the world. In Australia, we started in 2016. Adelaide is our headquarters base. And today we are operating in 4 states in Australia with a team of around 85 people. We primarily work with the electricity, gas, and water networks, but we're slowly getting into smart cities and applications of technology in smart city areas. Um, why are we interested in this? Because at Enzen we believe technology is already disrupting and is even going to disrupt the way energy, water markets, and smart cities will play into the future. We're seeing that happening, and we wanted to see how we can promote the application of technology with a real understanding of the business domain, and how we can help our customers through the journey. So what we have set up in this small space here is a kind of an experience center, because you need customers to touch and feel, understand how it can improve businesses, improve lives of consumers. And so we've set up different solutions across the office, some of them here, some of them in other rooms that we have, which is all around smart community, smart energy, smart work, and smart asset management. So things like smart street lighting, which is on my left here, smart waste management, and things like that in the smart community space. In asset management, we've got solutions for digital asset management, digital twins, control systems in the cloud, virtual power plants, and similar things in the work management space. So this is just a start. We had our minister here last week as a first external visitor who we showcased some of the things, but we are continuing to build, and we want to partner with the universities here, etc., to see how do we keep the solution updated and very much in tune with what future technologies are going to offer. So thank you once again. That's about Enzen. Anup from my team leads our IoT practice, so he'll be more than happy to talk you through if you want to understand a bit more about what IoT technologies we have got going currently in this building and with our customers. So with that words, I just want to say thank you for coming and have a wonderful evening. Thank you all.
Gotta pick this up. Really bothering me.
So good evening, everyone. Thanks, Dilip, for the introduction, and thanks, Leo, John. This demonstration center was put together at really short notice, especially with me hassling both John and Leo. Come on, guys, please make it happen in 2 weeks' time. So they did it. So thank you once again. We did have this vision to have a showcase of multiple communication technologies in IoT. So what you're seeing around this office here is a mix of LoraWAN, Wi-Fi, NB-IoT, GSM, a mix of radio comms that demonstrates across different technology platforms between the private networks and the public networks, and that's really a big collaboration that we have here. So after the presentation, feel free to talk to us, and we can take you around and give you a bit more insight on what we're doing. Cheers. Thank you.
Hi everybody, my name is Craig Lawton. I'm from Melbourne, so don't hold that against me. I used to love coming across to Adelaide when I was a kid because I've got 4 cousins here. Every time I come in on the aeroplane, I see all the grids of Adelaide, and I remember being half asleep in the back of a, what was it? It was a station wagon, face pressed against the glass, seeing the lights of Adelaide as I was coming in late in the evening. So it's always been a really nice spot for me to come back to. So I look forward to coming across here a lot more as well. I was asked today by Leo and John to come in here and tell you a little bit about LoraWAN and how it works with AWS IoT. So who's familiar with Amazon Web Services? Who's keep your hand up if you've built something on Amazon Web Services? That's good. So I'll talk a little bit about the AWS IoT services. In some respects, I'm making a big mistake being here today because we're in the middle of our big customer conference in Vegas, which happens every year. And so it's just a steady stream of new announcements and that you'll want to ask me questions about and I won't know anything about. So we'll cover some of them at the end. I've got a couple of little demos here that'll show a LoraWAN connection using the Things network for a little sort of maker style device and also for a GPS tracker. And just show how you could string together some of the services in AWS very quickly to build a useful solution in the IoT space. So who's familiar with LoraWAN? Yeah? Okay, so we might, I don't know how long we'll spend on that because I didn't really know too much about you guys until I got here. So this is where our IoT services stand as of 2 days ago. There's some new ones that are coming out. So in 2015, we launched the IoT service, which is this one here. It's now called the IoT Core Service. So this, if you create an AWS account, you get a single endpoint in the cloud to send your IoT data to, and you can have the devices talking to each other via that endpoint, but you can also have the devices talking to cloud services. And it uses MQTT. Everyone familiar with MQTT? Yep, and there's a pub-sub broker in there as well. So you can post messages onto a topic, and then you can subscribe to topics or wildcards and topics and start to take actions on it. So that was launched in 2015, so it's a few years ago now, and that was all we had. And then it's evolved really quickly. We call it the core service now because we've added quite a bit more. We've added, in 2016, the AWS Greengrass service, and that was built on the realization that you've got billions of devices connecting to the internet, and those devices are getting more and more powerful, so you can actually make use of that compute out in the edge or the mist to do some interesting workloads. So we realized that, okay, we'd been telling people for a long time that, shut down your data centers, everything's going to the cloud, but then we realized, well, there's all this compute out there in the world, so let's make use of that. So we came up with our edge platform, which is called Greengrass. And what that looks like, if you're a technologist, is you install a runtime on the device. It'll run on virtually any kind of connected device. And then you can register that runtime with your cloud account and you can deploy functionality down to it. So you can write code, Lambda code, in Python or Java, JavaScript, and you can then deploy it to run in the device. So why might you want to do that? Well, I was speaking to a customer who runs a theme park, and they were looking at having some logic to shut down the ride if there were particular problems. It's not the one you're thinking of, by the way. And I
should have been using it.
Possibly. So, if they want to shut down the ride really quickly based on an error condition, do you want a round trip to the cloud? Which could be in the Sydney data center. So it's when you've got that low latency kind of response, it's really handy to have the code running right out in the context where you are. Other reasons for it, sometimes you don't want to send data to the cloud because you want to shrink the area of concern for compliance and privacy and regulations. So one thing that we're seeing a lot of interest in is using Greengrass to do image recognition at the edge, using models that you train in the cloud, and then you extract from the image the data that you're after, and you only send that data to the cloud. And then the final reason people might want to use the cloud, use Greengrass to do processing at the edge is because they've got lots and lots of data. So sometimes we've got customers perhaps who are running wind farms out in remote areas, and they've got a lot of data, a lot of telemetry coming off all the equipment, and they want to collect all that, and they don't want to send that over a really, long, expensive network. They want to process it locally and then only send the relevant data up to the cloud. So there's some of the reasons for an edge platform, and AWS Greengrass is our edge platform, and we've got some functionality around. You can have a local IoT broker in Greengrass, so you can have messages talking to a local Greengrass runtime just at the edge, and you can also deploy machine learning models to be inferred down at the edge, and you can do some other things as well, and there's more coming in that space. Moving on from that, we announced Amazon FreeRTOS a year ago. That's a real-time operating system for microcontrollers. So FreeRTOS is the most widely deployed, might be widely deployed as well, but it's widely deployed microcontroller operating system for very low-powered devices. And it's interesting that as devices get more powerful, some people say, why isn't it sort of Linux, say, taking over all the devices? And it's because the cost price, the price of devices is getting lower and lower and lower. And as the price gets lower and lower, the number of use cases widen. So you sort of, if you've got a pyramid of your supercomputer at the top and you've got your smart light bulb at the bottom, that bottom bit is getting wider and wider all the time. So Amazon FreeRTOS, that is built on the FreeRTOS, which is open source, and it's just got some connectors so that you can connect it to Greengrass and you can connect it to our IoT service. And it's got some other features around over-the-air updates and that type of thing. And then the other three, I won't go into too much depth, but device management, that was born out of the realization that some of our big customers are managing millions of devices. So how can you index that and take action on large numbers of devices, do configuration changes and force software updates at scale? Device Defender, are you familiar with the Mirai malware virus, or is that so long ago that everyone's forgotten it? When the default passwords on the webcams, when they weren't changed, and they took down one of the world's largest DNS providers, and so IoT security is very important. Device Defender will look for anomalies and misconfigurations, and you can set what you expect for normal behavior. And if you see abnormal behavior, it can actually take action using device management to actually, say, reboot a device or take it off the network and that type of thing. And IoT Analytics, that is a place where you can store real-time all the data that's streaming into the IoT service. And you can use that directly to build things like predictive maintenance models. So if you're developing an engine around, I don't know, I'm just making it up now, say a jet engine for a plane, and you wanted to collect all the data about when failure occurs based on sensor information, you could use our machine learning services, which I can't cover today, in the cloud to work out when the jet engine's likely to fail based on historical data, and then you could deploy that model to you could use that based on the data that's been coming into the service from your real jet engine, use that to train the model, and then you could deploy that out actually into the wild to actually infer when failure was likely. So that's all the services. There's a lot more coming, and I'll cover them at the end, the new ones that are coming our way. So when I'm talking about low power networks, I tend to talk about constraints. Things have constraints in the IoT space. And you're probably familiar with all these. Energy limitations, network latency could be a problem, price is an issue. And typically you have to compromise and choose one of those constraints to live with. This is where low power wide area networks have come into play, because they allow for long range communication, they don't require much power, and they're only good for low bit rates, but you can also cover really long range applications. And it's really good for a lot of applications where you just want to put something out and leave it for 5 to 10 years if possible, and not have to revisit it, and hopefully not have to reconfigure it either. And there's some of the technologies you've heard of, that Narrowband IoT, Sigfox and LoraWAN are different types of low power wide area networks. And if we compare low power wide area networks to other networks, you tend to see, as I said, longer range, longer battery life and more efficient. So I was speaking to the guys from Meshed. Does everyone know Meshed? It's the local partner for Things Network. And he suggested I buy one of these. and one of these. This is my LoraWAN gateway from home, and he doesn't know where I live, but he did text me. Paul, do you know Paul McManus? Anyone? In any case, Paul texted me and said, "Do you live out in Mitcham in the eastern suburbs of Melbourne? Because I just pinged your gateway from the aeroplane." So just goes to show it does go a long way. And the previous time I flew to Adelaide, I had a Sigfox version of this, and I've just put together a bit of a web front end that would track the GPS on it. And I thought, I finally finished it like months after I was in Adelaide, and I was going, what the hell was I doing in Western Victoria? And I worked out, yeah, it was the aeroplane pinging some Sigfox network in Horsham or something like that. So they really are long range. And I'm not sure if you're meant to have these on an aeroplane. They're technically a transmitter, aren't they? I'll find out one day. It's unlicensed spectrum. It talks to some of the features. I'm happy to share. This is something I found on the internet, which talks around some of the comparing the Sigfox and LoraWAN and NB-IoT. I tend to think LoraWAN, you have to set up the network yourself, but you can do bi-directional traffic, which is good, send a little bit more traffic. It's different in every geo. Sigfox, you don't need to necessarily think about your network at all. As long as you're within range and you've got the device, you can connect. And NB-IoT is for applications where you've got a bit more bit rate, you want a little bit lower latency, but you also have to, you're sort of, whatever capabilities available from your telcos is what you're stuck with. Excuse me. And this just talks around the comparative pricing of the different types of solutions. It doesn't have Sigfox in it, but as you can see the quality of service versus the pricing. And this talks around the relative battery life of different solutions as an example. So LoraWAN solutions are great when you don't want to change the power on the thing. So LoRa is, and LoraWAN, it's built, and it's really hard to stand here, sort of look at my screen and do this at the same time. Apologies. I like to face the audience. It's developed on top of LoRa technology. It's managed by the LoRa Alliance. You might know it's unlicensed spectrum. That's one of the reasons it's so cheap. I did take it to Europe, and I had to unplug it because apparently that's the GSM band over there. I forgot. So you have to be mindful of which country you're in, which spectrum. And over here we've got two competing spectrums, so we've created a challenge for ourselves. That's roughly what the LoRa looks like. It's built on the regional bands at the bottom. There are different classes of communication. The demo today is Class A. That's got to do with when downlink information comes and other differences of the type of class of traffic. Yeah, Class A is the most energy efficient, and I'll show you. I'll show you a downlink packet coming from AWS IoT to this particular green LED. You can see that it's Class A. It can sometimes take quite a while to get going. So the way LoraWAN works is that the end devices, like this, and like the green LED there, connect to a LoRa gateway, like this device. This is $455. I bought it from IoT store. So it doesn't break the balance sheet. Just downloaded the global configuration from the Things network, and I had it going in surprising. I think I allowed half a day to do it, and it took about an hour. So it's quite good. If your device goes out into the world and it can connect to multiple gateways, or connect to multiple gateways, and the back end will work out, demux the traffic as it's coming in. So that provides a layer of redundancy and extra coverage. And everything's encrypted twice in LoraWAN, so it's encrypted to the network layer, and then it's also encrypted at an application level. LoraWAN has this concept of an application, which I'll show you soon. So if you're a graphical person, and I like to see pictures, this is roughly the architecture of a LoraWAN network. You've got devices, talking to gateways. They can have multiple connections. And you've got what's known as a network server, which I've simplified here. There's a lot of components inside that, which acts as, if you like, the control plane and data plane for the network. And then it routes traffic to applications on the back end. So the Things network is all hosted in AWS, so it makes it a little bit easier. That network server is in our data centers, and the applications for my demo is in the data centers as well. And when we're looking at integration of a LoRa network with AWS IoT, some of the things that you need to consider are these four things here. You need to think about bidirectional information, because LoraWAN is a bidirectional protocol. So you need to think about how you support traffic coming in and going out. You need to be able to integrate with our shadow service. And anyone heard of our shadow service? John, who's never built anything on AWS IoT, has heard of our shadow service. So I'll show the shadow service in action. That's how you can update the state of things without actually having a connection. And you should be able to convert between the LoraWAN data and JSON. So these technologies send data in really compressed payloads, which is made up of bytes. If you're a software developer in the cloud, you don't like dealing with bytes. You like dealing with JSON, a nice descriptive data payload. So you should think about how you convert between the two. And then all the good stuff around, if you've got an integration, you've got to make sure it's rock solid for the use case that you have, that it'll scale and that it'll stay up. And so, if we go into a diagram showing a little bit of how the LoraWAN network, as the Things network, can integrate with AWS IoT, you've got the end devices and gateways. The network server is in the cloud, as I mentioned, just by coincidence. The Things network is a good partner of ours. And then there's this thing, AWS IoT integration. It's a box there. I'll explain what that is in a little bit. And that allows then the data to be converted from bytes to JSON, to be forwarded onto our IoT core service, and then back again. Now, some of these icons you might not be familiar with. That's just indicate our core service. Our core service has rules and actions that you can take based on the data. So you can set up a rule to send data, say specific data on a certain topic or certain attributes of a payload, directly into a storage service or a database service. So a little bit on the demo I built, and I can share the GitHub link with you afterwards if you want to have a little bit of a play with it. This is made by PyCom. It's a low Pi 4 device. It's built on an ESP32 microcontroller. It's got a PySense shield on it, which I'm using just basically to read the temperature in the room. So it's sending the temperature up to the cloud. The state of this thing is the color of the LED. So the state at the moment is green. So this could, you could have a smart lighting, for example, and you might want to change the state to a different brightness or something like that. If you want to change the state of an object, you want to be able to send data down to the device and change it. So I'm going to, if all goes well, change the color of the LED to show how that works. And yes, I've used the Things network, which you guys are all familiar with, of course. So we don't need to go too much on that. This is my architecture video they did with us, where they talked about how they use AWS to build their service. So with this PyCom device, there's lots of data on how to get started. It runs a version of Python, MicroPython, so Python's taking over the world, so you should be familiar with all that. And it's got a plug-in to, you can use Visual Studio or with Atom. And I've got a Mac here, so I'm using Atom. You go through and set up the board, update the firmware as usual. Then you configure it in the TTN console. I'll show what's happening end to end. So maybe I'll skip out of this. I'll skip across to seeing something for real. Hey? That was a bit disappointing, wasn't it? Here we go. So this is the Things Network console. Has everyone seen this before? Has everyone had a bit of a play in the Things Network? So this particular application, you can see at the top, if you can read that, it says applications, TTN, PySense. So that's an application I created for this particular device here, this one that's reading the temperature. And it's also got a state, which is green. So if you can read this, it's sending up this payload. The last one up was 0BAB02, and that got converted into a colour of green and the temperature of 29.87. It always runs a bit hot for some reason. So that data has come up through my gateway that I've got on, even though there's a gateway on this building apparently. I don't like to run without it. And it's gone up into the cloud. So this is coming into the Things network, and then there's this integration, which was that box before. It's actually deployed as a CloudFormation template. So has everyone heard of CloudFormation? Not some people. So when you create environments in the cloud, you can point and click and create everything piece by piece in the console, and just store your servers, your databases, your storage network, and create an environment. And that's great when you're starting, but after a while you want to deploy your cloud-based applications as code, because then all you need to do is change the configuration and you can change the environment. You don't have people manually changing things, and you can create multiple environments. So the way you do that in the cloud is you use a CloudFormation template, and that describes all your components in that environment. So you can create one, and then if you want to create another, you can just stamp out this template and make multiple stacks. So it's just a method of deploying infrastructure as code in the cloud. So the Things network provide a CloudFormation template which deploys the infrastructure in the cloud to integrate between their network and our AWS IoT servers. So you can just get that off them, and they update the versions of the software that's running in it and the infrastructure. And so if you get a new one, you can deploy a new version of the template and update it. So it simplifies that deployment. So this is the two parts of the stack which were deployed. It has some things in there, like when you deploy the template, it asks for the credentials on the Things network side and asks for the credentials on the AWS side, so that it can capture the traffic coming in and put it across, so it has the right privileges to do that. So that's the magic rectangular bit in the middle that I simplified before. And then this is the console for the AWS IoT service. The AWS IoT service, you can configure the devices in here, but there's also this test client, and the test client's great for seeing that traffic's actually coming in, and also debugging, and also for demoing. So this particular one is I'm subscribing to this topic here, plus devices, plus up. Now it's it's got some wildcards in. The plus can be substituted by anything else, but that's the topic structure that the Things network integration publishes the information into. So you can see this payload came through November 28, 7:15 p.m. Is that me, or is it now? Yeah, Eastern time. Oh yes, that's right. I haven't updated my laptop to Adelaide time. So you can see a whole bunch of extra information around the LoRa network there, but you can see, if your eyes are good, you can see it says green and 28.56. And so this information's coming straight in. So this is coming through the service. You can then write a rule that can capture this information. You can say particular devices or all the devices, some of the attributes, all of the attributes, and then you can put that into a rule. I'll show you quickly a rule. You can put it into a rule here. I've got a bunch of rules, so I don't, not in Singapore I don't. So I'm running this out of Singapore at the moment. And this rule is just, it's like anyone done any SQL programming in their life? Sorry, yeah, it's unfortunate, isn't it? That it's useful, if painful. So this is a select statement that's selecting some of the information out of there, and then the action is to put it into DynamoDB, which is our NoSQL database service. So as the data's coming in, it's being put into this database. So there's no servers built, there's nothing there. We manage the scale, so this is just one device. If you had 1 million devices, it's the same architecture. It'll just come in and you can put it straight into a database, and then you can use that for analytics, or you can build a mobile app on front of it, so that you can see where everything is. You can do anything with it in that respect. So it's very simple architecture and scalable architecture for deploying IoT solutions. And also it's important to understand, when we deploy a region-wide service like IoT, it's across a whole region. And so what that means is, physically, the infrastructure is deployed over multiple data centres in the same region. So in Sydney we have 3 availability zones. So the IoT service is distributed over at least those 3 availability zones in Sydney, which gives you a lot of reliability in the service. So that's an end-to-end. Now, the interesting thing is, that's data coming in. What happens if you want to send data back? So we have this concept of the shadow service. Now, I'll skip back to the thing here for a second. I'll show you what the shadow service is. I'll sort of show this. So this is the just show you quickly what the rules engine. This is the IoT service. The rules engine can send data to DynamoDB, but to about 14 different back-end services. And you can also send it to a Lambda function, so you can effectively send it anywhere. It's going through a little bit of what we've said already. You can send data directly using a rule in action to other devices. So what I wanted to do is to show you what the shadow service is. So what I wanted to do is to, in the cloud, as a developer, have ability to request that this device change its state. And as a developer, I don't want to sit around waiting to see when this connects to change state. I just want to publish it and say, I want to change the state of this thing. And that's what the shadow service is great for. The shadow service is great for getting and setting the state of things when you're a developer who doesn't want to deal with the physical handle for physical networks and all of that type of thing. I'm not having to go to developers. I'm just sort of, if you're a developer and you like doing reconnects and all of that and polling devices, that's fine. So the device shadow works a bit like this. You have this concept of a desired, reported, and a delta state. So the reported state is the last reported state from the device. So this, you might have seen, was sending up to the thing saying, my reported state is green, okay? You might desire to change that to red, and you say, my desired state is red, and then there's a difference because the state is, the difference between the reported and the desired state, and that can trigger an action by the device itself. So it works a little bit like this. You've got a device, you've got a fan there, but this is, just imagine it's my little device. It goes, my current state is green, and it stores that in the IoT core service and the shadow service, which is part of that. You're a developer and you say, oh, I want to know what the state of that device is. Instead of querying the device, it queries the shadow service and it finds out the device is green. That's good. It goes, actually, I want to change it to red or blue. Which colour are we going to try and change it to? Red or blue? Red? Nobody likes red. Okay. Blue? And the device shadow gets its updated state and goes and says, okay, I see my desired state is blue, and it goes and updates itself with its desired state and reports back that it's now blue, and then the application developer goes, okay, that thing has actually changed to blue and it's confirmed back. So as a developer, all you had to do is say, I want the state of my thing, the shadow state, to be a different state, and then you just wait for the reported state to get updated.
So does that state change happen straight away, or the next time the device checks in or something or other?
So we'll do it.
Okay, all right.
Okay. When my gateway caught fire in Sydney, it still happened because I was in the middle of Sydney and there's a Things network up there, but it took about half an hour just as everyone left the room. But when I've got the gateway here, it's usually within a minute or so. So we'll have to be quick with the console so you can see it happening in flight. But So, go to, so you can see the payload coming in. These are all uplink information. I can go here to the shadow. This is me manually changing the shadow. So if you're a software developer, you do this programmatically with the API, but you can do it in the console. So we've got a shadow here, and this is what it looks like. It says JSON payload says desired state is green, reported state is green, and you can edit it in the console to simulate what an application developer might do. So you might say blue was the agreed colour, blue, and we save that. We go back to the things network, and you can see there's a scheduled downlink.
So it pushes that straight away.
Yep, so it's scheduled, so the next, it's a Class A communication. Oh, shit, sweet. So that allows you then to change the state of things using, the software development methods that you use in the cloud, but have that state honoured down to the device.
What do you mean by scheduled?
So with Class A communications on LoraWAN network, it only receives downlinks after it's a send and uplink.
Oh, okay.
So to change its state, it'll say scheduled, and the next time a packet comes up, it'll.
So we were just lucky that an update happened.
Just lucky, yeah.
Immediately. Yeah.
Yep.
Okay.
Yeah. So sometimes, as I said, in Sydney when the device failed, it still happened, but it was happening off some Sydney gateway that took, it took half an hour. But sometimes that's you're okay with that.
Due to lots of packets not being received or whatever updates.
I was in a sort of a concrete jungle,
Okay.
hotel.
Yeah.
I'm not too sure. Yeah, I didn't get down and do my packet tracing at that stage. I was just happy to get out without burning the place down. But it'd be interesting to go into a little bit more depth. So that's what the shadow service does. The other thing I wanted to show just quickly is this GPS tracker. Has anyone seen one of these? This is an Oyster. Yeah, does anyone want to see it? It's it seems to be triggered when it moves. So I think somewhere in there, when you move it, it can. Yeah. And I think that's a way it minimises its power usage. That if you just leave it in your drawer for a while, it's not using any power. Feel free to pass it around because something might happen then on the screen as well. This I've set up a different application for this one. So if I go to the Things Network, I've got a different application, Oyster demo. You can see the data coming in. As you can see, it's a long payload, so you've got to convert that into Latin long. There's this cool feature in the Things Network which will do, you can put in these little JavaScript functions to convert between patterns. And this particular device, somebody's already provided you with the JavaScript code to convert that payload into Latin long and other things. So if you have a look at the decoder function there, it goes on for quite a bit. It turns the payload into Latin long. So the bytes arrive at the Things Network, goes to the Things Network back end, and then before it goes to the application, it does this decode of the information. So if we go to the IoT network, this is actually in the Sydney region, just to prove that you can do it in Sydney as well. This is the data that's coming through from the device at 7:25 PM, and you can see that it's been decoded. There's lat and longitude there, and a bunch of other information.
So that function, that was a Lambda function, was it?
So that function in the Things Network isn't a Lambda function.
No?
The Things Network provide the ability to do decode and encode functions in their back end.
Oh, okay.
Funny enough, with the Sigfox version of that, they don't have that in their back end. And so I implemented that for the Sigfox version of the Oyster as a Lambda function.
Oh, okay.
What I did was I had just the raw bytes coming to the IoT service, and then I had a rule that said send that to a Lambda function, and then I extracted the information and put it from the Lambda function into a DynamoDB. And I can actually show you the data that's coming in for this is actually going into this one table here. I've got Sigfox Big Mate decoder data. And this is what DynamoDB looks like. This is a table, but this is me filtering on this device CCL, which is my initials, Oyster, which is the device. If I get rid of the filter, just refresh. So it's not filtering on data. Let me just, I was going to show you the Sigfox devices, because I got one in my car back in Melbourne. Okay, it's not playing. I've got to do something else to change the filter. But this is the Latin long devices coming through for that. I have done it for the Sigfox as well. I can show you afterwards. What I did just before I came in here, while I was at Nando's, while I was covered in hot spicy sauce trying to type, is I took all this data here and exported it. You can export this as a CSV. Export a CSV. I exported a CSV file, and then I brought it into our QuickSight service. And with QuickSight, you can bring in a data set, and one of the easiest data sets is you can just bring in as CSV. So I just brought that in, and then I just created a geospatial object. I just dragged the Latin longitude out of the file onto the thing, and then the color is the device. And then I zoomed all the way in, and these are the spots where it, you know, just before I came here, that I'd been pinged. That device had pinged the network. So you can see you can start to build quite interesting solutions without having to do too much heavy lifting. And as you can see, I live east of Melbourne, so there you go. So that was, we've also just at reInvent announced a way of taking these QuickSight dashboards and embedding them in your own applications as well. So if you wanted to build something like this, you could build it into your own application. And this is just something that I just put together today, so it was a lot of fun. But don't try and use the Oyster in Europe. It doesn't do much. So if you're interested in seeing what's happening in the AWS cloud, keep an eye on the Twitter feeds and the tubes and see what's happening. So thanks for listening today. I hope you've learned something new.
Thank you. Do you want to take any questions? Are there any questions at the moment for Craig?
I don't want to keep people from food, so just come up and ask, okay? If you've got any questions, that'd be great.
Anoop, do you want to do a bit of housekeeping in terms of, just from a Things Network perspective, this is the last meetup for this year, so thanks for coming along, and hopefully we'll see you in the new year. The first one in the new year to keep on the framework side of things will be Azure IoT, and then if anybody in this room has sorry no we are neutral here, so the other one was if anybody has a contact for Google IoT, a human that I could talk to, please pass them along. So we actually want to present the frameworks, available frameworks out there. Excellent. So I'll come back to you on that one. Oh, two. You have to come along for the next few.
No, like from my AWS perspective, how you prepare yourself?
Like
I'll catch up afterwards, okay?
He doesn't want it recorded, obviously. Yeah, that will be late January, and then we'll keep going on a monthly basis. In terms of the Thing Network, there's probably, if you want to have a update, talk to me afterwards in terms of gateways rollouts and what's happening there. We've sort of covered that fairly well the last few meetups, so I don't want to not hold you from food. So if there's no more questions, I'll hand over to Anoop again, and he will sort of tell you a bit about the housekeeping. We're together. We've got a few more dashboards and a few things to actually look at.
The food and labels are just on this side over here. Please help yourself to it. I encourage you to start talking to whoever you can find, Enzen and Craig, and just get to know more about the products. There's a lot of products demonstrated on the wall over there. There's IoTs everywhere. So feel free to engage. There's Kenny, who's the dashboard guru, who's sitting right behind. Put your hands up, please. All right. So he's actually helped us build the dashboard. So there's a few different people who's you can relate the conversation of today's topic to. So by all means, stay, ask us, play with the toys, and have fun.
Thanks, guys.